While browsing for new models, I saw a stunning bombing plane from World War I period. I wondered how would it look with different color palettes. Then I decided to make a shader to customize its colors. If you have ever watched my third episode in this Unity shader graph series, you would definitely know how to achieve that by using the Tint Mask technique. In a short summary, we will have to do the following steps. The first two are loading the albedo texture and the mask texture. Then we split the channels of the mask texture to separate the masked areas. The next step is tinting each area and combining them together. Actually, we already achieved the purpose right after this step, but I usually push one step further to expose the color in the inspectors by using the blackboard feature of Unity shader graph, because after that I can change the colors combination anytime without touching the shader. Each of these steps were already described with details in the full video, so if you haven't watched it yet, I strongly recommend you to do so. Really. Now we go back to the point where we decide which part of the bombing plane will be painted with which color. By following the voids inside my head, I decided to keep the original colors for all the wooden and the metallic parts of the plane, because both their colors and patterns are so unique, and I don't think that I can give a better choice about coloring than the author, so it's better to leave them as is. One more plus point about this choice is all the shiniest parts come from the metallic parts, so we don't have to spend a channel just to control the highlight areas anymore. About the other parts, I split them into three groups. The first one is the wings and the tails. They will be paired with the primary colors. The body will be painted with the secondary color, and the pilot chairs, they will go with the tertiary colors. Then I realized that changing the color of the chairs doesn't bring much value. Its color should be the same as the wings for better contrast most of the time. Moreover, when the body is painted with a bright color, the name carved on the surface is very hard to recognize, so it's better to control the cover parts by a distinct color. Since we have 4 separated black and white masks, moving a region between the masked areas means we need to add that region to a destination mask, then remove it from the source mask. If somehow it's overlapped with the albedo mask, that origin must be removed from the last one, aka albedo mask as well. It's fine if we change our minds only once or twice, but repeating this process is tedious and boring, so I have to come up with a smarter method. Our multiple masks contain the information about the shadings or the brightness levels and the masked areas. We are finding a much more convenient way to control the areas, not the shadings. We'll leave them alone. That's why we will use 2 textures, one for encoding the shading levels and another for the masked areas. Then, whenever we want to transfer a region between the areas, we just need to repaint it with the target color, and that's it. Only a minor change is made to our shader graph. Instead of loading a single mask textures, we load 2 and multiply them together. Nothing more. In fact, if you follow the tutorial to create the shaded mask from the black and white version of the albedo, there's a big chance that you'll end up with this. The plane looks more like a plastic toy. It's way too clean. It's because the difference between the light and dark areas is too low. The contrast was somehow modified by the process of converting a colored textures into a black and white one. Moreover, the original contrast level may work well with the original color palette, but not for our customized versions. Then it's better to control this contrast level ourselves. The hard way is recreating the shaded mask over and over again in Photoshop or GIMP until we're satisfied with the result rendered in Unity, where the lights, the shadows, and the environment will be taken into account. It can lead to a very different look in comparing to the raw texture. If you get to know me, you can predict that I won't be happy with that repetitive way, and you're right. I prefer adjusting the contrast right inside Unity with some sliders. It's a perfect time to learn about the contrast node of the shader graph. It allows you to control the contrast of the texture. Increasing the contrast means the dark area becomes darker and the bright area becomes brighter, all based on an exponential formula that you may not care about. It takes two inputs, the textures and the contrast level, and the output is the texture with the adjusted brightness. Brilliant! With this setup, we can preview the result right inside Unity, and more important is the final look with the lighting and the surrounding environment. The previous two changes bring us greater control over the Tint Mask technique, and much less effort needs to be spent on pre-processing the textures, but it doesn't come for free. We need to pay the price by increasing the complexity of the shaders. Every single pixel of those textures are manipulated at runtime to prepare the mask for the Tint Mask technique. This process is repeated every frame, even when the result is the same. In order to eliminate that overhead, we need to save the processed texture once we are satisfied with the adjustments. In that case, we can tell that it is baked. But we don't want to lose the flexibility to adjust it anytime either. Well, where there's a will, there's a way. We are indeed able to get the best of both worlds. Let me introduce my friend, Mixture. It's a tool made for Unity Engine to manipulate the textures without destroying the original version. We can easily make changes and preview the output texture. The result can also be used directly, or it can be exported as a normal texture. In the mixture graph on the screen, I'm trying to distort a rectangle to make a lightning bolt. Every aspect of this lightning bolt can be customized, including color, shape, or even the additional particles. By adjusting these parameters, I can generate thousands of its variants without drawing. After installing the package following the instructions in the home page, you can start by creating a static mixture graph. Static means the output texture is baked only once before entering the play mode, and then the texture cannot be changed during the runtime anymore. We don't need that either, so a static texture, or we can say a baked texture, is good enough in this case. Since Mixtures is a similar node-based interface, I guess you won't have much trouble getting familiar with it. Let's follow these steps. Step number 1. Load the original albedo texture as the first input. Step number 2. Create a shade map using black and white node. You can play around with the settings over there to suit your needs. Step number 3. Use the node contrast to adjust the brightness level. After modifying the texture, some pixels may be darker than black or brighter than white, so to ensure that those values will fall into the 0 to 1 range, we'll use the clamp node in the step number 4. Step number 5. Load the colored mask and multiply with the shaded texture. Finally, set the result as the output textures asset. You may feel like home using this tool, not much different than the shader graph. After saving this graph, you can see the output in the inspector already. You may not notice yet, but you have just automated the process of converting any albedo texture into the Tint Mask. You didn't hear it wrong. Any albedo texture can be passed into this graph as the input, and the corresponding Tint Mask texture will be produced immediately as the output, in the blink of an eye. That asset can be used directly as a normal texture in the shader graph. Now we can revert the Tint Mask shader graph back to its classic and simplest form, combining a single colored mask texture with the albedo. Now you are free to control how the original albedo is converted into a black and white shade map. You are free to adjust the contrast level of the shade map as well. You can also increase or decrease the brightness of that texture. Any color-coded areas can be transferred freely by simply repainting them in Photoshop or GIMP. Last but not least, from Unity's Material Inspector, you can create any colors combination you want anytime. All of those features, and the shader still runs as fast as a lightning bolt. That's how powerful it is once you found the sweet spot to optimize and pick the right tool to do the job. In case you didn't notice, I also added the sharpen node in mixture to enhance the crispiness of the lines, since I think it's essential to emphasize the hand-painted brushes. All of the mixture inputs are also exposed in the inspector for even more convenient when adjusting the parameter. Mixture is not the only tool capable of performing this magic trick. There's a custom shader graph node called Shader Graph Baker, allowing you to use the shader graph itself to manipulate and bake the result out as a texture. It's free but quite limited, since it's just a personal project. You can also find a paid project from the asset store, also called Shader Graph Baker. It has the same name, does the same thing, but costs you $25. In return, you can get a better support, I suppose. Alternatively, you may have heard about Substance Designer. It's a much more sophisticated tool to create procedural texture. Of course, by being a product from Adobe, it's undoubtedly expensive. And don't forget Blender is a well-known all-in-one software. It's mostly designed to create 3D models, but recent versions allow the user to bake the procedural materials out as textures. From my point of view, Mixture is still the most reasonable option, regardless of its previous state. Some of its advantages are: it's free, it stays inside the game engine so you don't have to switch between multiple tools, thus reduces the iteration loop. It's integrated well with the game engine, so the output can be used directly like any normal textures. It looks like shader graph. It works like shader graph, so the learning curve is much more shallow in comparing to the alternatives. Moreover, it supports real-time textures. And lastly, it can be customized and extended further via custom nodes and C# script. To summary, in this video I have introduced 3 methods to improve the Tint Mask technique. Number 1. By separating the shaded map with the color-coded mask texture for easier adjustment. Number 2. By using the contrast node to control the brightness level of the shaded map without recreating it. Number 3. Baking the pre-processed textures as the final one using Mixture, thus the texture is ready to use in the shader graph. And by baking, we have optimized the shader performance at runtime. All of these fancy stuffs here are just the beginning. A single technique can be used in many different situations with countless variants. Just keep finding the room for improvement, and hundreds of better versions will come to you. What would you do if you need to customize 8 colors instead of 4? Like this? Tint Mask is a cool technique to customize the colors. It can save disk space and memory as well. Much more information about it can be found in the full video, including the colors manipulating, mask texture creation, blah blah blah. You can also visit our fan page to discuss more. or subscribe to this channel for not missing any upcoming videos. Thank you and see you again.